Keenan, you're with me. So, on the front, girls, recording there just a second here. Thanks, Dakota. So, find the area of each of these shapes. You know these formulas now? You have the formula sheet though, right? So, the thing to remember, get your sheet out. Do you know where it is? Like the formula sheet, the one with all the... Yeah, because we're going to need some of these things here. And if you're watching the recording, get your formula sheet out as well. Because for a rectangle in general. You have what I'm talking about now? What's the area of a rectangle's formula? Yep, that's the sheet right there. I think it is. Yep, I'm looking from a little distance. So you find your rectangle on there, and rectangular area is length times width, right? See that one? In this case, we got 2 feet. We'll do this one without a calculator. And the width, no, I got them back and forth, whatever. Length and width, 2 feet and 4 feet. It doesn't matter if you put them in the correct order because they just multiply out to 8. But the unit is important. Single tick mark meant feet, so I put FT because it works better if you put feet squared with FT. Okay? Now for a triangle. On your sheet, got the area of the triangle, I think it's on the right side, right? Half base times height. Yep, that's what we're saying. Making sure you're in the right sheet. So 1/2. Base and height. Now once again, sometimes you got to play around with the triangle. Remember, just because this is, I'm going to sketch it approximately. Just because it's off like this doesn't mean you can't think of the triangle and just twist it in your head. And it didn't matter if you twisted it this way or the other way. Still has a base of 4 inches, 7 inches in height. As long as you can imagine it twisted around. So you got a direct height and a base. So with this one, you can enter 1 divided by 2 on your calculator, or if you know it, it's just decimal 5 times the base of 4 inches. The height is 7 inches. When you put that in your calculator, you confirm later on what you get. It should be 14 inches squared. Shouldn't have said that out loud, but your check. Yep, good. Now the circle formula. Write on your formula sheet, by the way, as for formulas for circles, you need this pi value. There's a pi button on your calculator you can use, but 3.14 is a good approximation for our problems. What pi is. Why do I say that? It's because the area of a circle is pi r squared. That means 3.14. The radius, in this case, that's the distance from the middle of the circle to the outside, is 1.5, and then you square it, meaning 1.5 times 1.5. You have the square button on there, I've never seen in your calculator. You come up with an answer for me in a second, yeah? And we'll round it to 1 decimal place. So yep, 3.14 times 1.5, square that. Which one? So did you go 3.14 times 1.5 and then you hit the square button on the 1.5? Let's just see. Equals. Yeah, just wait, that's it equals. So, yeah. Okay, you got it. Now, when you use 3.14, you get 7.065. 7.065, we can round it properly. I said to one decimal place, because I want to show. Proper rounding means don't call it 7.0, call it 7.1 meters squared, okay? The meter squared is necessary for full marks. Now, this chart here. Oh, bumps up there. Now, don't read these page numbers here, just copy and paste it yourself. In this activity, you have no partner because you're ahead. We'll examine the geometric nets of common 3D solids, shapes, and make formulas. Well, some of them don't work out to like a really nice formula, but faces is how many sides you have on something. You want to do this one for sure. Then, it kind of gets bogged down in here. You can do this one easy enough. The number of each type of face. So like on a rectangular prism, you'll say, well, they're not all the same, but there's however many triangles. Triangular prism, you'll say how many rectangles, or I said triangles, sorry. On a rectangular prism, there is 6 rectangles of various sizes, though. And say the area formulas for each of the different types of shapes. And total surface area, formula for total surface area. There's really not enough space to work in here, but tell you what, this one doesn't work out well for a good, these two don't work out well for a formula for just every case. You'll have to just draw them out and figure them. But this one does here, and I'm going to give it to us. 2 pi r squared plus 2 pi r h. But with that formula sheet and so on, you'll see some stuff. Now, what are you going to do? This will take a little while. I'll give you scissors and tape too. You're going to calculate the total surface area and put it in your table, but the formula things, like I said, you can do later. Now, what are we talking about here? We're talking about this shape, for example, a rectangular prism, a box. You're going to use a ruler to measure these, measure them, and like, you know, measure whatever, 7.2 centimeters. Put it inside the drawing because you're going to cut out the other stuff. This is 3.1 centimeters. Measure it here. Put it here too, you know, on the other one. 3.1 centimeters, because when you bend it, you won't see that maybe. Maybe this is 3.2 centimeters, whatever it measures here. Now, I just made those numbers up, but you'll measure those. And then you can find the area of each rectangle. Then cut this out actually and put it together as a actual box. The second page is empty because you're cutting out the paper. A triangular prism, same thing here. You can measure the height and then measure the base. Put those in there. You'll measure the rectangles and calculate their areas. You might as well do the areas like right on these two, by the way. You know, length times width. If this is like 5.2 centimeters, this is 11.5 centimeters. Just calculate right in the middle here so that you have it when you pull it up. Area is equal to 5.2 times 11.5. And then come up with your centimeters squared answer. We'll erase those numbers, like I said, I'm just making up measurements. But measure things out, then cut and fold, and make sure you write everything on the inside. This here is like a soup can. See, the top is the circle. You'll have to find about where the middle is and measure the radius. And then you can do pi r squared. You can probably fit that in here. A equals 3.14 times the radius squared. You can measure this rectangle with centimeters. And then you're going to find out, though, that there's a shortcut formula. It's on your formula sheet. More about that when you get to that. This one here, if you cut this half circle, this semicircle out, you folded it up, it makes like an ice cream cone. Eh? And then you put this circle as the cap. So like, you know how like, oh no, you guys don't get drumsticks like that. But anyways, you know what I'm talking about with a drumstick? You ever see the flat drumsticks? That's exactly what this is, eh? Anyways, teepee is a cone upside down, right? And the ground is the circle on the inside. So you'll measure the radius for this one too, from the middle to the outside. You'll figure out something, make it look like a cone when you got it all figured out, okay? There's a formula for this, by the way. Look at the bottom of your sheet. It says cone, side area. Your formula sheet, the single sheet under your calculator. What's the cone's area? Side area. You see that? RS, right? So this area is equal to pi RS, meaning the slant height is the S. When you cut this out, you'll have the R, the radius is from here, the circle, but the S slant height is the half distance here, S. And you'll figure out what that is. And then you'll figure out what the radius is, and you can just calculate that. Okay? But there you go. And I'm going to turn it over, get your scissors and stuff started up. You should be set. And I'll stop.